This is a video for AQA Further Pure Mathematics, Vectors section 2.8, where we're looking at the perpendicular distance between skew lines. So remember then that skew lines are non-parallel lines and non-intersecting. So we will be given two lines and their respective equations and asked to find the shortest distance between them. Now by the shortest distance we mean then a line joining the two lines L1 and L2, so XY on the diagram, which is perpendicular to both L1 and L2. So the method of solution of this is similar to what we've already done with distances between lines and point to line, in that we can do it by finding the relative vector OX and then making sure that that vector is perpendicular to both lines by using the dot product. So the method goes as follows then. We take points x1 on line L1 and y on line L2, and from those we find an expression for the vector xy. We then need to show that that is perpendicular to L1 and L2, and we can do this by finding two dot products, the dot product with each of the directions for L1 and L2. That's going to give us two sets of equations, because these dot products must both be equal to 0, so we get simultaneous equations for the two parameters lambda and mu. If we solve those, we can then substitute them into our expression for xy and find the length of that vector xy. So the method now I'm going to look at with a particular example. And here we have our lines R1 and R2 with these equations. Well, from the equation for R1 we can write down that the position vector of x, OX, is equal to 1 minus lambda, negative 1 plus 3 lambda, and 2 plus 4 lambda. In the second one we can get an expression for OY, and that's equal to 2 minus 4 plus 3 mu, and then 2 mu. From those we can then calculate a vector xy, remembering that xy is given by OY minus OX. So we just need to subtract those two, and we can see then that gives us the following. xy is 1 plus lambda, then minus 3 lambda plus 3 mu, and negative 2 or minus 2 minus 4 lambda plus 2 mu. Well, the next stage is to write down expressions for the dot products of xy with each of the directions. So the dot product xy with the first direction vector negative 1, 3, 4, and that must be equal to 0, and also then the dot product with xy and the second direction vector, which is 0, 3, 2, and that must also be equal to 0. So those two dot products are given here, and from those we can calculate an equation from each of them which includes lambda and mu. What I suggest you do now is just pause the video and to work out those two equations for yourself, and then come back to check that you get the correct values. Well, if you write down the dot products and then simplify them, you should get the following two equations. So 26 lambda minus 17 mu is negative 18, and 17 lambda minus 13 mu is negative 13. So putting those two together, solving them simultaneously, we can find values of lambda and mu, and you can check that you get the following two values. Well, these values of lambda and mu we can now substitute into our expression for xy. So there we have xy, and we're going to substitute lambda is minus 13 over 49 and mu 32 over 49. If you do that, we find that xy is given by this expression, and then the usual method for finding the magnitude of this, of course, is to use Pythagoras' theorem, and so that gives us the following, which gives a value of 6 over 7 for the magnitude of xy. Well, that concludes this video on finding the perpendicular distance between skew lines, and indeed concludes the series of videos on vectors too.